Good day everyone, I am Camille Suliasa and for today I will be doing a reflection video about Mars Climate Orbiter Failure Board Release Report for my final assessment. It consists of 5 questions to answers. So, without further ado, let's get started. Number 1 is, what is the report all about? The Mars Climate Orbiter Failure Report's inquiry brought to light the collection of negligence and communication failures that culminated in the unfortunate loss. One of the main problems indicated was differences in units of measurements. The base of the ground software that handled thruster performance data used English units, while still conversely it was metric unit in spacecraft navigation. This kind of mix-up turned out to be a fundamental mistake since it caused the wrong calculation of trajectory during landing on Mars. The navigation system would have interpreted and thus analyzed the thruster performance data in consistent metric units since these results were factored as English units. As a result, the orbital corrections were miscalculated by faulty navigation algorithms in this spacecraft's equation. However, as Mars Climate Orbiter approached the Martian atmosphere and began moving downward based on poor calculations of its trajectory, such a low orbit resulted in large atmospheric drag and stress that were orders of magnitude higher than what the orbiter was prepared to take. This resulted in the sudden dismantling of the spacecraft, putting it out of operation well before time. Number 2, what are the issues of the case? The issue of the case are inadequate consideration of the entire mission as a total system. The Mars Climate Orbiter Mission Failure Investigation Board discovered that the mission team had failed sufficiently to consider how all the components of the particular mission interacted with each other. This resulted in such difficulties as separate measurements unit for various elements of the spacecraft. Another one is inconsistent communication and training. The Mars Climate Orbiter Mission Failure Investigation Board concluded that there was a lack of team communication and training influencing team involved in the mission, and it resulted in miscommunication and mistakes. Another is lack of complete verification of navigation software and computer models. The Mars Climate Orbiter Mission Failure Investigation Board established that the navigation software and computer models utilized by the mission lacked adequate test verification. This contributed to miscalculation in the spacecraft. Another one is undetected errors in ground-based computer models. In its report, the Mars Climate Orbiter Mission Failure Investigation Board indicated that there were errors in computer models used to monitor spacecraft advance with respect to this mission. These mistakes caused erroneous orbiting of the spacecraft. Another is insufficient system engineering function. The Mars Climate Orbiter Mission Failure Investigation Board concluded that the mission system engineering function was weak. It implies that there was not sufficient for unify all the different components of the mission. Next is informal communication channels. The Mars Climate Orbiter Mission Failure Investigation Board found that the mission team had relied too much heavily on informal communication channels such as email and voicemail that led to lack of documentation and made it difficult to track what was happening. Another is lack of peer review for the navigation team's work. The Mars Climate Orbiter Mission Failure Investigation Board found that the navigation team work had not been adequately peer-reviewed. This means that other experts were not given the opportunity to review the team's work, and identify any errors. Another is insufficient training and process familiarity. The Mars Climate Orbiter Mission Failure Investigations Board found that the mission team had not been adequately trained in the mission procedures. This led to errors in the execution of the mission. Last one is inadequate verification and validation processes. The Mars Climate Orbiter Mission Failure Investigation Board found that the mission's verification and validation processes were inadequate. This means that there were enough checks in place to ensure that the mission was on track. Number 3 is how NASA addressed the issue. After the report, NASA took steps to correct it by implementing improvements for Mars mission that are still going on. This includes better arrangement oversight, scrutiny of operational procedures in context, and enhanced communication among teams. The Mars Climate Orbiter incident resulted in a more critical analysis of the processes that were supposed to develop mission-critical software by NASA. This brought about tougher standards on unit uniformity, better quality control arrangement, and a reorientation towards systemic perspective in project management. Moreover, NASA developed a need for quality training and education to be provided by their teams responsible for planning of missions, as well as their execution. The mishap of the Mars Climate Orbiter made it clear that designing a proper understanding between hardware and software systems is what makes up the foundation in which NASA operates. Therefore, NASA undertook to renew its training programs in which a way that one can include all-encompassing courses on system integration and software validation, as well as the dangers of unit mishaps. Number 4 is how important the knowledge of digital signal processing and communication in space technology. The Mars Climate Orbiter incident clearly highlights the importance of digital signal processing and communication to space missions. The success of any mission is dependent on the accuracy in data transmission and correct calculation. Digital signal processing and communication techniques can help to correct errors in terms of data transmission and signal processing, as they act to mitigate any noise or interference that could occur during this process. What is more is preventing risk due to signal loss can also be done by means of additional communication laying and duplicating data backups. In this sense, the case serves as a clear example attributing even the slight rules within these spheres might lead to tragic results and gives to rise to stress testing, validation simultaneously of standards in space and technology. Number 5 is what are your takeaway or learnings as a future computer engineer based on this case? With an eye toward becoming a computer engineer, the applicability of this case remains evident through several key takeaways. To be precise, paying keen attention to details plays a critical role, as this is especially important when working with complicated systems, since even the slightest mistake can lead to catastrophic failures. The need for interdisciplinary team to develop effective communication and collaboration practice is undisputed. In addition, from this case one can observe that the importance of continuous learning and improvement should be constantly emphasized, as it is possible to understand better how appropriate quality control measures need to be applied while designing space technologies. The Mars, the Mars Climate Orbiter failure serves as a stark reminder of the potential consequences of human error in complex engineering endeavors. As a computer engineer, or as a future computer engineer, this case inspires me to make my work inherently thorough, an impartial endeavor for high-level system thinking to continuous learning. The hard lesson I take away from all this is the commitment to develop technology where nothing comes easy, but success makes it worthwhile.
And that would be all. Thank you for listening.